Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hi, how you doing? And a very warm welcome back to youtube.com/Wi-Fi Sheep with me, Tom. And this, my first video, not that I follow trends or anything, but my first ever video celebrating Macintosh. That's right. Every year the Mac community, especially the classic and retro Mac community, get together and produce various bits of content, mainly here on YouTube, about classic Mac ownership, projects and repair. I thought I'd join in. As many of you might know, I originated as a Mac user. The Macintosh was the very first machine that I actually used. Actually before 8-bit BBC Micro and before Windows PC, which might surprise many people. And I'm not just talking about we got an iMac in 1999. I'm talking about my father used Macintosh during the sort of end of the late 1980s into the beginning of the 1990s, and that's when I was first exposed to it. So I've had quite a long history using the Macintosh system. Now ideally what I'd love to have is one of the original Macintosh 128s, the 512, the Plus, or even something like a Macintosh SE or Mac Classic. I don't have any hardware like that, and these particular machines, especially here in the UK, are not common. They're quite rare to get hold of in some cases, and also, as I've seen in many other YouTube videos and projects posted online, the reliability of this now aging and in some cases 40-plus-year-old hardware is diminishing by the day. So it's not a hugely attractive proposition, I have to be honest. What is an attractive proposition is this, which I happened to see randomly on eBay the other day. So I'm not sponsoring this or anything, but I will just show you. So this is a kit which I found online. There's many of these online for an Apple Macintosh Mac 128, what's called the PicoMac with SD card, which uses the Raspberry Pi Pico microcontroller as a basis for a self-assembly and very, very low cost, less than £15, so probably about 15 to 20 US dollars. Very low cost, very small little board to actually build, in other words, an emulated or semi-real working Mac, which I thought was really, really cool. So I ordered one and it literally arrived the other day. Here is from the Royal Mail, so internal UK. It was a UK seller. I think the project originated from the UK anyway. And inside are some parts. So there's this relatively small double-sided PCB. The connector here is already put in situ for me. It's not soldered, but we have here VGA video connector. And then we have a baggie of parts, and there's a little instruction label, quite nicely printed, which actually shows you where to get some files from. So we may have to come back to that in a moment. So we'll just take that out. And then we have a collection of parts. Very few parts, very simple. 2 resistors, some pin header. Here's a micro SD card reader, a diode, and as I already mentioned, we had the board and the VGA jack. What it doesn't include is the actual Raspberry Pi Picos. Luckily, I've actually got 2 variants of it here. These have come from the Pi Hut. They're anywhere between £4 to £8 roughly each, depending on the spec. So I have this one, which is a slightly newer Raspberry Pi Pico 2, and this one, which is the original Raspberry Pi Pico. Now, this project can use either or, and although the Pico 2 I think runs a bit faster and has more RAM on it, there's no benefit to this project at the moment. That's not to say it won't change in the future and will have some benefit. But for now, I think I'm going to stick with the original Raspberry Pi Pico. And this is a brand new one. They literally are relatively low cost microcontrollers. They're extremely powerful though. So they have, I think it's like 200 and I want to say 40K or something of RAM. ARM Cortex. So it's a dual core ARM Cortex M0. It's Raspberry Pi's own silicon, so it's not an off-the-shelf chip. And yeah, these things, I haven't done a lot with them, I'll be honest with you, being quite an unusual 32-bit architecture. But for these projects, this is absolutely fantastic and exactly what we need. Now, you might notice that my Raspberry Pi Pico is missing some header, and we do need some header. So again, this came in from another supplier. I have a various header pack here, and we're going to need a bit of extra pin header. So mainly one of those. Two of those for the Raspberry Pi Pico. And I'm also thinking I might add some socket header here so that when we plug in the micro SD card, we can take it out. It's not permanently wired, because I might want to change out going from micro to full size SD at a later date. The other thing I'm not hugely keen on is the power that's used for this board here is a surface mount component, and I'll be very honest with you, I'm going to chicken out. I don't really fancy trying to solder that on today. I like through hole stuff, that's fine, but surface mount is not my favourite at all. So what I was thinking, I've got here, just carefully push these bits out of the way. I've got here one of my random component boxes, and I've got a few adapters made up already, including this one. So this is the same micro USB power adapter already on a little board, wired up just with positive and negative power, and then going through a switch. So what I was kind of thinking was it'd be nice to have a separate switch supply so that I can actually power this board on and off from a switch, something it won't do in its current configuration. It won't be too difficult to tap the board to do that. We can actually probably tap it from underneath. So yeah, that'll be fine. So my soldering iron is just off camera over here, and it has been heating up. Now I will just show you the soldering iron quickly. So on my particular cameras, because my cameras don't filter out things like infrared or ultraviolet light, the soldering iron, when it's on and heats up, actually emits this strange purple colour. That is not in reality, that is just what you're seeing because the camera isn't filtering out the actual light spectrum it's giving off, but it doesn't mean it's on and literally red hot. So first off, let's start with putting the header onto the Raspberry Pi Pico unit. Now to do that, the quickest way is, if you've got a piece of solderless breadboard, then you can put the pins into the breadboard like so, and then the Pi unit can sit straight and neat on the header like that, and that's much easier to solder. For soldering, I always use flux. In this case, I'm using a liquid flux. Don't use the solder flux pastes, especially the ones that are, well, you can if it's for electric components, but if it's plumber's flux, that's a big no-no, because I made that mistake and I'm still paying for it years later with stuff that I soldered up with plumber's flux. Bit of wet sponge, just clean up the ends of the soldering iron. But try not to drip water everywhere. It doesn't really matter if we have, it's not critical at the moment. Bit of solder, and always just start with the corners. There we go. There we are. And now I'm just going to go along and solder up all the other pins. Make sure we make good connections on all of them. Okay, that looks all right, I think. Might just touch that one up there, just to be on the safe side. There we go. Yeah, excellent. Now, just to help get it back off the board, just got a flathead screwdriver. There we are. And yep, that's looking all right. Want to make sure that you've not bridged any of the pins on the top, and I haven't. And yeah, that's looking great. let's turn our attention to the main board itself. And am I missing a part, or do we have a third resistor somewhere? Because I'm only seeing 2 resistors and a diode. Is my kit missing a part? Which would be annoying. If it's a 100 ohm resistor, that's not a problem. I've got those in stock, plenty of them in stock. So that's a bit annoying. Okay, never mind. We'll carry on. So we can put these. Luckily, the 66 ohms, which are things I might not have in stock, are both here. So we'll put those through. I always tend to just bend out the other side just to keep them in place. I'll have to go and dig out a 100 ohm resistor in a moment. I absolutely 100% will have one in stock somewhere. And we'll put the diode in. Now the diode here on the silk screen indicates a stripe. Diodes have to go in one way. The stripe is the silver part. So we're going to bend the diode and we're going to go in kind of like that. Again, you might need a pair of pliers just to help get that straight or flat, but there we go. Okay, I'm just going to go and dig out a missing 100 ohm resistor, and then we will look at soldering all these onto the back. Okay, I have gone through every piles of resistors I've got, and it's always the way, you can never quite find the one you want. However, I think these should be 100k. Brown, black, brown, I think from memory is 100. Let's just test it with the multimeter. Multimeter is in 2k ohm mode. Let's just pop over the side and see what it comes back with. 101, yeah. 99, 101, those are 100 ohm resistors, not 100k resistors. You don't want to get the two confused. Okay, that's fantastic. So we can use one of these in place of what I think is missing out the kit. So no biggie, problem solved. So resistors like these aren't polarized. They can go in either way. It's just the diode has to go in the correct way around, which it is according to the silk screen. So those are the bits we've got done so far. I'm just going to apply a bit of flux again, and we'll get these soldered in before we do anything else. Okay, resistors and the diode are in, so let's just cut off the remainder of the legs. And then we'll just solder on the VGA video lead, or port I should say. Okay, that's looking good. VGA connector is on. So you have got these two lugs here which take the stress out of the board being pulled back and forth. If you're happy you've got it in, then you might as well flood these with a bit of solder. Okay, so yeah, that's looking all right. That's in, so it should be okay. So next we've got the header to go on. Now what I want to do is I could just solder my board straight on. However, because I will want to be able to take these out in case I want to do upgrades, or if this for whatever reason fails, it's nice to put the pin header on, so it gives you that option if you like. So pin header is on like that. Now what I sometimes like to do is, we'll do this one at a time, is just use a little bit of blue tack just to secure the header so that it tries to stay relatively straight, doesn't lean over too much. That looks okay. Not ideal, but it looks okay. Just put the just try and put the other one in for support. And what we'll do is, again, not forgetting to add a bit of flux, like so. Just tack in the ends. And that will secure it, so we can check if we are happy with how that is. Yep, that's looking all right. So I'll put the other one in. I should probably try and put the board in now, if we can. There we go. So we know when we tack in the next lot that the board will actually be in and it will actually fit okay. And yeah, if we're happy with that, which I am, we can just go ahead and tack in, or I should say solder in, all the other pins. Okay, excellent. So that's in and doesn't look like anything's bridged, which is fantastic. So that's why I use the flux, just to make sure you can flow nicely between the connectors. So that's in, which is fantastic. So now the issue with my connector for the SD card. Now, the original plan here is you actually solder this in direct. That's how the kit's meant to work. I actually want to put a piece of pin header or a piece of female connector on here. I haven't quite got a piece long enough, but I have got this piece, which actually is looking a little bit used. Let's see if I've got a fresh part somewhere that we can use. And that's ideal, because that's actually the right length for what I need. So I'm going to put this in. So basically it's sockets, and then we can do a mechanical fit. So I can change this out, or I can take pins from this if I need to. It's much easier later on, especially if I want to make modifications or tweaks. So again, we'll just pop in a piece of blue tack just on the side. Get that relatively straight, which, yeah, that's looking all right. Again, flux it up. There you go. That's great. Take the blue tack off. So fundamentally that's the board more or less finished. All I want to do now is, obviously we need to just get this tacked in correctly. So let's go back to that piece of solderless breadboard and let's put these pins in, and we might need our blob blue tack again just to help support this board from drooping forward. So we're going to put, just get this in shot. Okay, try and get that so it's sitting, yeah, that's okay. Again, flux. There we go. Simple as that, done. So we should be able to pull this out. That pin head is now attached. Let's take our breadboard out of the way, and that will now sit in there like that, and that's now adjustable, or we can take and swap out the SD card reader if we want, as well as we can swap out the Pico. Okay, so I'm just looking at the pinout on a Raspberry Pi Pico. The Pico 2 and the Pico 1 have exactly the same pinout, and the silk screen is on the underside of the board. So the boards are like that. We flip them over, and that gives us the idea of what the underside is. So I want to add my little circuit here, or my external power supply, which I'll just tack in for now, and I'm going to tack it to the underside of the board rather than trying to solder this, which I just don't fancy, in all honesty. So the first thing to do is let's just create some clean cable at the end. So again, I forget what this came out of, but I've rigged it up for something, and it'll be fine for what we need for today. So That's ground. And this is going to be our voltage line for 5 volts. I should probably add a proper pair of wire strippers for this, really. Let me just see if we can just... There we go. Tiny wires, probably need some slightly thicker wire, really, but it'll be okay for this. So, we want to... First, we need to ground the switch. So, on the Pico, let's just make sure we are the way around. So, it's this way around, and we can see the silk screen underneath. You can obviously bring up the pin out online as well. So let's ground. So ground is this pin here is ground. So hopefully I can just tack this wire onto here. He says, perhaps not. Put a bit more solder on there. Try that again. That's better. Okay, there we go. So that's now ground. And the voltage that goes through the switch wants to go onto V, which is the next one, which is this one here, which is V system bus or system, because the Picos do have a tiny little voltage regulator on board that can bring 5 volts down to the required 3.3 volts TTL logic voltage which they use. So if we tap this into here, there we go, switch is in. And I'm just going to double check to make sure I'm right. So, and I might actually want to be on the voltage bus. So, my bad. I am going to, and I can actually see the traces. So this one isn't connected to anything. I actually want to be next door. There we go. Right. Okay. Yeah, that's fine. So, 5 volts is coming in on voltage bus. Sorry, not voltage system. And ground is obviously attached to ground here. So that should be, from a soldering perspective, our little Mac 128K actually finished. Okay, so next we need to look at the actual firmware and emulator image that's going to make the Raspberry Pi Pico turn into a Mac 128K. If I could just bring your attention to this resource. This is the original project on GitHub. This is PicoMac. And it's an emulator called UMac, which is new or relatively new, created basically for running on microcontrollers. Here is the entire project, and with this repository from GitHub, you'd need to build this yourself using the tool sets available from the Raspberry Pi Foundation for the Raspberry Pi Pico. I will just at the bottom here give credit to the project. So this is Matt Evans who created this. I don't know him personally, but cheers, Matt. We really appreciate the work that you are doing. However, there is this website, Pico Micro Mac, which creates custom images pre-compiled for you. So it's a simple download, which is actually a little bit easier. So we have the original configuration, and we also have down here this additional configuration, which expands us from the original 128 all the way out to a higher resolution. And also more RAM, so 208K Mac, which never existed in reality, but we could use here, SD card, and also the VGA, enhanced VGA resolution going up to 640 by 480. I might try this just to see how well this goes. So let's click and download that image, and it creates this precompiled .uf2 file. Now, if we take our Raspberry Pi Pico just out of the board for a moment, try and clean some of the stuff out of the way, and let's get an appropriate USB cable, and I've got one here with an adapter on it, which will be fine. So it's micro USB, and we'll just plug this end over into our PC. Now on the PC it should bring up a window. It'll treat the Pico as if it's actually a flash drive space. And what we can do is we can click and drag our download and we'll copy it straight on. And it will immediately dismount once it's done the copy. So that's completely normal. Okay, so it now means that hopefully the Mac software and the emulator and a ROM image and operating system are all now flashed internally onto this Raspberry Pi Pico. Let's put the Pico back in. Okay, so I've got my USB, old style Raspberry Pi USB, micro USB power supply. And we're on at the wall, which is fantastic. I've got my little switch here, which now if I press my switch or flip the switch, we power up. And if I flip my switch back, we power off. Fantastic. That's actually now working. So I suppose the next thing to do is look at some kind of display. We have a VGA out, so we could just plug straight into a VGA monitor, or we could try something else like this. So this came in today, and I ordered this in preparation for this project. So this came in off AliExpress straight from China. It's not sponsored or anything. I have just literally bought this. It wasn't terribly expensive, at about 30 odd pounds. So what's that? 50 US dollars, something like that. But it's a little pricier than what I'm normally used to spending. But inside should be the connector parts for a small VGA compatible flat screen display. Got a remote, a lot of bubble wrap in here. So in here should be a 4:3 aspect ratio. There it is. 4:3 aspect ratio, 7-inch colour LCD display. Now the original Mac had a 9-inch black and white CRT, and I did and ah about going down the CRT route, but I've only got 5-inch CRTs. So just let me actually get into this. Okay, there we go. There we are. Power supply. Oops, ribbon connector. Got a protective layer on it, which is good. And then we have here, this is the driver board. So we have power of some description. We have HDMI in, VGA in, and composite video in. So these things, I love these boards. They are so versatile in their use. We have this ribbon to ribbon connector, so we need to connect in our ribbon. I hate these ribbons. So let's just connect that in. And then put that down. So that might be okay. We'll see. Oh, I see. So power van goes in there. Okay. So that's our display. We will need a voltage of some description from that barrel jack. Let me have a think. Okay, so I have a 5-volt power supply for the display here. So that's looking good. We'll pop that in like that. Let's just do a quick test. Power up. Hey, there we go. That's looking all right. I'm just giving myself a little bit more space for you to see what's going on. So we'll pop that there. It does come with a little control panel, which we could put in. We might need to put in as yet, but let's have that like that. Now, I've got here, this is my Mac. And I have RGB to RGB cable. In reality, I'm thinking a bit more of a, it'd be nice to have a sort of face-to-face solution that these cards would clip into each other. But for argument's sake, and just for now, let's do this. So let's plug the Mac into one end. and again it's a tension on the cable, trying to sort of just position things so this works. We can get the VGA in the other side. Okay, that looks all right. It's a little bit haphazard, but we're in. Okay, so turn the VGA back on. I'm just going to kill one or two of the lights, so there we go. Get a slightly better view of what's going on the screen. And now let's turn on the Pico. Let's see what happens. Okay. Oh, there we are. I think my ribbon cable's a bit loose, but it's there. I can see it. I kind of might need to adjust my ribbon cable a little bit. Look at that. That actually worked. That's amazing. It's absolutely amazing that's actually worked. So I guess what I might need to try now is I have here a adapter. So let's just power back down a Pico board. I have here an adapter, so let's pop this adapter into the USB, and then if I apply or add a USB mouse, so I have a mouse here, will this work? This is a bit of a convoluted pile of stuff at the moment. Will this work? Okay, zoom in a little bit so you can see the screen. Let's power back up. Switch is just here. Takes a moment, doesn't it? Okay. So does it see the it sees the mouse, and the mouse works. And it actually works. Oh my goodness, it works. That is amazing. About the Finder. And it's gone nicely full screen on the display. There might be a little bit of artifacting that I need to deal with. It might not be, the ribbon's not in quite right, because it's very flickery the minute I touch it. So I think my ribbon's not in right. But yeah, that's a bit of all right, isn't it? That works, which is pretty awesome. Now this disk image is preloaded into ROM, so this is giving you the operating system. I'm just really chuffed by that, actually, how well this works. So there's a couple of games, things like Load Runner, System Folder, Empty Folder. Of course, this is before you actually had to shut down on your Mac. So yeah, this is very early indeed. Oh, we have got MacLeod and Matte Paint. Does Matte Paint work? Doesn't, because you need to have a scratch disk, and of course it can't write any file, but it would work. Obviously the 640 by 480 pixel image is I'll say that it's okay using the extra space. It's not used to having the extra resolution though, so that's what's actually I think causing it a bit of issue at the moment. But no, fundamentally I am really chuffed with how that is actually working. So we have built, it's extremely crude and I've got stuff everywhere, but we have actually managed to build a Mac 128 literally in a couple of hours on a Saturday afternoon here on the workbench, which is fantastic. Okay, so I'm going to leave this project here for now. I want to have a play with this setup, just see if I can sort of dial it in, get it working a little bit better. Really thrilled with actually how well that has worked literally out of the box. And hopefully we can come back to this with a few more revisions and see if we can actually make something a little more Mac-like in the near future. Happy Marcintosh, everyone. If you haven't done so already, please do consider liking and subscribing, and I'll see you real soon right here on the channel. Until next time, bye for now.